In today's lesson, we are going to be solving systems of equations algebraically. So let's go ahead and look at example 1. Y equals the quantity of x plus 2 squared minus 6, and y equals 4x minus 2. To solve a system of equations, we want to know when both of the equations will be equal to each other or where they will intersect at the same time. So since we're doing it algebraically, we want to know when both of these functions are going to be equal to each other. So we're going to set them equal to each other. So I'm going to rewrite it as x plus 2 squared minus 6 equals 4x minus 2. So all I'm doing is plugging in one of my y values, 4x minus 2, for the other y so that I can set them equal to each other. So when we solve this, we need to expand x plus 2 times x plus 2. If you need to, you could make a box on the side. You have x and positive 2, x and positive 2. X times x is x squared. 2 times x is 2x. 2 times x is 2x, and 2 times 2 is 4. So when I rewrite this out, I would have x squared plus 4x plus 4, and then I simply need to bring everything else down. We need to combine like terms if we have any, and on the left side I have positive 4 and negative 6 I'm going to combine. This would simplify to x squared plus 4x minus 2 equals 4x minus 2. At this point, we want to go ahead and get the equation equal to 0. So let's go ahead and subtract 4x and add 2. Subtract 4x and add 2. When I do this, they cancel out on the right side. And let's look at the left. I don't have anything to combine with x squared. 4x minus 4x is 0, so I didn't need to write anything down. And negative 2 plus 2 is also 0, so it goes away. So I just have x squared equals 0. Now that I'm here, to get the x by itself, all I need to do is take the square root of both sides. The square and the square root would cancel out, and this would give me x equals 0. So since I only have one x value right now, I know that this system of equations is only going to have one solution. But the solution of a system of equations is a coordinate, so I need to find my y value. So I'm going to plug this x back into the easiest equation, which would be the linear. So when I do this, I would get y equals 4 times my value of x, which is 0, minus 2. 4 times 0 is 0, minus 2. So y equals negative 2. So my solution is going to be 0, negative 2. Remember, it's x, y. So there is the point of intersection of this system of equations. All right, let's look at example 2. It's y equals x squared minus 2x minus 3, and y equals negative 5. This time, I'm going to show you guys a different way of looking at it. I know that my y equals negative 5, so in the other equation, I'm going to plug it in for that y. So it would become negative 5 equals x squared minus 2x minus 3. I know that this is a quadratic equation because of the x squared, so let's go ahead and get it equal to 0. That means we need to add 5 to both sides. We wanted the equation to equal 0, so we get 0 equals x squared minus 2x plus 2. Okay, so now at this point, I want to see if I can maybe factor this so I don't have to do the quadratic formula. So I know that my a times c would be positive 2, and that my b is negative 2. The only multiples of 2 are 2 and 1, and they need to add, since it's positive, to 2, and I can't get that because that's positive 3. So it's not factorable. So let's go ahead and find the solution by doing the quadratic formula. So start with x equals your blank plus or minus the square root of b squared minus 4 times a times c all over 2a. We know that the opposite of b goes in the first blank. My b is negative 2, so I would put positive 2. It's b squared, so it'd be negative 2 squared minus 4 times your a times your c all over 2a, and I accidentally wrote a, so I need to cross that out and just put 1. Simplifying, we get x equals 2 plus or minus the square root. Negative 2 squared is 4. And then negative 4 times 1 is negative 4 times 2 would be negative 8. All over 2 times 1, which is 2. This simplifies to x equals 2 plus or minus negative 4 over 2. But if we look, we have a negative number in our radical. We cannot have this. So this means that both of these functions do not intersect, making this one a no solution. All right, so let's look at example 3. It's y equals negative x squared plus 2x plus 7, and 2x plus y equals 2. Both equations are not solved for y this time. Nothing changes, but I'm going to take this y value that I know and plug it in for the other y. This would make the new equation 2x minus x squared plus 2x plus 7 equals 2. I have like terms, 2x and positive 2x. This would make the equation negative x squared plus 4x plus 7 equals 2. I don't want to deal with this negative x squared, so I'm going to go ahead and move all three of these terms to the right side to get the equation equal to 0. So I'm going to add x squared, subtract 4x, and subtract 7. So I'd get positive x squared minus 4x and negative 7 on the other side. These all cancel out and become 0, which is what we want a quadratic equal to so we can solve. Nothing to combine with x squared, so I have x squared minus 4x, and 2 minus 7 is negative 5. Now we're ready to solve this quadratic. I'm going to check its factors. We want a times c up top, so that'd be 1 times negative 5, making it negative 5. Our b is negative 4. Multiples of 5 are easy because it's just 1 and 5. So 1 and 5. Which one needs to be negative for negative 4? It'd be negative 5. So if I write out the factors of this, my a is 1, so I don't have to divide by anything. I would get x plus 1 times x minus 5, still equal to 0. Zero product property says that x plus 1 equals 0 and x minus 5 equals 0. Solve these. I would subtract 1 and add 5 on the other. Cancels, leaving me with x equals negative 1 and x equals positive 5. This time, I know I'm going to have two solutions because I have two x's to plug back into one of these equations. All right, so let's take our x's and plug them into one of the equations. I'm going to use the linear. So I would get 2 times my first x, which is negative 1, plus y equals 2. 2 times negative 1 is negative 2, plus y equals 2. To get y by itself, I am going to add 2 on both sides, leaving me with y equals 2 plus 2, 4. So since this is the one where I plug negative 1 into, the first solution where I know these two equations will intersect is at negative 1, 4. Then we are going to plug in 5. So 2 times 5 plus y equals 2. 2 times 5 is 10 plus y equals 2. To get 10 or y by itself, we would subtract 10 from both sides, and we get y equals negative 8. This would make my other solution 5, negative 8. So here are both solutions to this system of equations. For today's practice, make sure that you are solving algebraically. You can use graphing the equations, though, to help check your answer. And I hope you guys enjoy your weekend.